everyone. Today we're going to learn about how to name covalent compounds and how to write their formulas. First off, what is a covalent compound? A covalent or molecular compound is one in which the bonds that are formed are due to the sharing of electrons. The valence electrons that are participating in the bond technically belong to both of the atoms that are involved. So for example, in the image on the right that shows a grayscale where the electrons might be located, the two nuclei are sharing the electrons, and thus the electrons spend most of their time in between the two nuclei. The sharing is generally considered localized, that is, it is in a specific location. The electrons are generally stuck between the two nuclei. There are very few exceptions to this rule about localization that we will encounter in this class. And another important note for future things we will discuss, the sharing does not have to be equal. For one of the atoms could take more of the electron's time than the other one. However, it would still count as sharing and therefore still be covalent. So, what kind of elements generally participate in covalent bonds? Covalent bonds occur between nonmetal atoms. In order to have that sharing of electrons, you need to have an atom that has a lot of electronegativity. Generally, nonmetals are the ones that have the high electronegativity values, because the further right on the periodic table and the further up you go, you find higher electronegativity values. There will also be a few metalloids that might appear in the covalent bonding here. For example, boron and silicon frequently form covalent bonds, such as in boron trihydride or in silicon tetrahydride. These are both covalent compounds that boron and silicon participate in. How do we name our compounds? The nomenclature for covalent compounds is interesting because we don't have a set formula when we have two elements combined together in this situation. Because of the sharing, they can be shared in many different ways. For example, nitrogen monoxide, nitrogen dioxide, dinitrogen monoxide, and dinitrogen pentoxide are all covalent compounds that contain nitrogen and oxygen, just with different ratios. So, since covalent compounds can behave in such a way, we must indicate how many of each atom is present in the compound when we give the name for the compound. And thus, the nomenclature, or rules for naming the compounds that are covalent, must involve prefixes that indicate number. We will show these prefixes on the next slide. The other thing that happens when we name this is that the second element in the binary compound will have its ending changed to "ide." For example, for CO2, the oxygen that is there becomes oxide. The prefixes that you should be familiar with are those for numbers 1 through 10. Prefixes that we will use might be familiar to you from everyday speech and other instances where you've run across numbered prefixes. If there is one of the atom present, then the prefix mono is used. If there is 2, we use di. 3, tri. 4, tetra. 5, penta. 6, hexa. 7, hepta. 8, octa. 9, nona. And 10, deca. There are additional prefixes for larger numbers, but we will not deal with them in this course. There is one exception to using the prefixes. If the first element that is listed in the compound would receive the prefix mono, you do not say it. So for example, for NH3, we would name it nitrogen trihydride instead of mononitrogen trihydride. It is implied, if there is no prefix at the beginning of it, that there is only one of that element. Please note, if the second element should get mono, it needs to have mono. Let's look at an example. What is the name of N2O5? First, we should look at how many of each element are present. There are 2 nitrogen atoms and 5 oxygen atoms listed in this formula. So, what prefixes should we use? The prefix for 2 is di, so the beginning part will become dinitrogen. The prefix for 5 is penta, so it would become pentaoxide. Having that A and the O next to each other is a little unusual, so you will find that most people traditionally will drop the A, simply to make it pentoxide and make it a little bit easier to say, although technically leaving the A and the O next to each other is okay. Also, since oxygen is second, you'll notice that I said oxide rather than oxygen. That is because the second element has its ending changed to IDE. Some elements only have one syllable taken away and others have many more. This is connected to the roots of these words, which are difficult to know unless you become familiar with just hearing it. So do the best that you can. So let's string it all together. The name of N2O5 is dinitrogen pentoxide. Let's do a second example. What is the name of XeF4? We have to consider what elements are present and how many of each. There is one xenon atom and 4 fluorine atoms. The fluorine will become fluoride since it is second. Xenon is first and would receive the mono prefix, but since it is first, I do not have to say it. So the name of XeF4 is xenon tetrafluoride. Let's take a look at a third example, but go in the opposite direction, going from a name backwards to a formula. What would be the formula for tricarbon octahydride? First, consider what atoms are involved here. What elements do you see the names of in this formula? In the first part, we see tricarbon, implying that carbon is the first one in the formula. The second part says octahydride. That hydride part is the hydrogen atom. So the second element must be hydrogen. So we have carbon and hydrogen. What are the prefixes that are listed and what numbers do they indicate? The tri in front of carbon indicates a 3, so it should be C3 for the first part of the compound. The second part has the prefix octa, which implies 8, so there must be 8 hydrogens. So the formula for tricarbon octahydride must be C3H8. Now that you know this information, good luck and go forth.